Sometimes we need to differentiate an expression that contains x and y. So it's not a simple expression where y is a function of x, but we have x and y mixed together. And we need to find dy by dx. And there isn't an easy way to do that. We have to integrate everything in place. We need to differentiate everything in place. So we need to differentiate every term. So we differentiate term by term. Each term, you differentiate it, and whenever you come across something that involves a y, use the chain rule and multiply by dy by dx. So let's start by differentiating x squared. That's straightforward. That's simply 2 multiplied by x. Now, when you multiply y squared, it's also 2 multiplied by y, but because it's y and not x, we use the chain rule and multiply by dy by dx. And then if we want to integrate differentiate 3y, the derivative is 3, or negative 3 in this case, but because it's y and not x, we need to multiply by dy by dx. And the derivative of 2 is 0, and the derivative of 0 is 0. So all constants, their derivative is 0. So here it looks like we've found dy by dx there. But actually we haven't found it. We've created an expression that contains dy by dx. In order to actually find dy by dx, we're going to need to rearrange this expression so that we have dy by dx on the left equals something else on the right. And that something else will be everything that doesn't contain dy by dx, in this case, the 2x. So we're going to have 2y times dy by dx minus 3 into dy by dx equals negative 2x. Now, we still, even though we have dy by dx on the left, we have 2 of them. So what you want is just one of them. So if we take dy by dx as a common factor and divide each of these terms by dy by dx, we end up with dy by dx times 2y minus 3. So that if we were to expand the brackets again, we would get this back again. So now our expression looks a little bit closer to where we want it, because in the end, we want dy by dx on its own. So we don't want this. So the easiest way to get rid of something you don't want on the left-hand side is to divide both sides by that same term. So our final step will be dy by dx equals negative 2x over 2y minus 3. Now, it doesn't matter if that negative you put up there or here or down here, as long as you have brackets, but I'm going to put it right here. So it's negative 2x over 2y minus 3. So that's the expression for the derivative dy by dx using implicit differentiation. If they had asked you to find the value of the tangent or of the gradient of the tangent at the point where x equals something, you substitute your value of x there, you substitute the value of x there, and here you'd need to find y, and you could find y by substituting x in there and rearranging. Okay, but right now I'm showing you simply how to differentiate using implicit differentiation. So whenever you come across an expression with a y in it, you differentiate as you would normally, pretending it was an x, but then you multiply by dy by dx. So you notice here when we differentiated y squared, we called it 2y, but then we multiplied by dy by dx. And the same here, 3y, we multiplied by dy by dx. We didn't do that for x, we only did it for the y because of the chain rule.